Say I roll 3 dice. What's the probability that the maximum across those 3 rolls is greater than or equal to 5? So first I want to find some way to simulate this. Let me say, how about just a is a random integer from 1 to 6. So let me look at a bunch of these a's and just make sure it looks good. Let's look at 100 of them. Yep, looks like it's randomly choosing numbers from 1 to 6. And so now let's make a table AAA. So each of these 100 instances is an outcome of rolling 3 dice. So here's the first roll, second roll, third roll. Okay, and then I start again. And then I want to know what's the maximum of this. And now I want to know what's the probability that that maximum is greater than or equal to 5. And remember, the way that we estimate probabilities is we do a bunch of experiments. In this case, we're doing 100 experiments. We count how many successes there are, and then our estimate is number of successes divided by number of experiments. So let me call this my table. And now I want to count how many values in here are greater than or equal to 5. And we're going to do this using patterns, and I want to show you a couple different ways that we could do it. So let me call it success. Success is going to be equal to count of my table. And then I want to count all x's such that, so the most obvious way to do it from how I've been phrasing it is count all x's such that, so that's front slash semicolon, x greater than or equal to 5. And then what would our estimate be for our probability? Let's call it probability. This would be success divided by this 100 number. And if I want to get it as a numerical estimate, I'd put it inside this capital N. And we could have done that in our heads once we saw the 66. 0.66, so about a 2/3 probability in this case. So let's do it a little more systematically. Let's define n, which will be the number of experiments. Let's define that to be 100. Then instead of writing 100 here, I'm going to write n so that I can update it more easily. And then let me put everything into the same cell so that when I update it, I just have to do it once. And I'm going to put semicolons after everything other than the last one. So I'm going to run it again. All the parameters are the exact same, but because of this my table being defined randomly, I don't really expect it to be 0.66 again. I expect something a little different. So here it's 0.71. And I should have done divided by n to make it more dependent on this variable name that I chose here. And now that everything is dependent on n, I can do a lot more. Let's try 1,000,000 experiments. Okay, so total it was doing 1,000,000 times 3. It was doing 3 million dice rolls and then computing the probability of the maximum for the set of 3 rolls being 5 or 6. So let's run it again and see how similar it looks to this 0.703. Yep, looks very similar. Again, I get 0.703. Another way I could have done this, that in some instances maybe would be better, I could have said, let's count x's such that x is equal to 5, or x is equal to 6. And so again, I got 0.703, so that's looking good. So this isn't better as far as x greater than or equal to 5, but what if we wanted to know what's the probability that the maximum is either 4 or 5? Okay, then I could just change this to a 4. And the probability is about 45%, it looks like. Let's run it again. Yep, again about 45% for the probability. And notice that we made it with these 2 vertical lines. Same way we made it when we were working in MATLAB. If I were to ask what's the probability that the maximum is 3 or 4, it's going to be much lower. Okay, probability is down to 25 or 26%.